Paper and Al.
Here to give you a little video podcast of nautical charts. We've got some groovy music in the background, played by Tommy Guerrero. The album is called Loose Grooves and the Bastard Blues. It'll be setting a nice mood for this chapter.
Certainly. Nautical charts put the maritime world in microcosm and let you navigate it safely and see on the little world everything you're seeing on the big world in a way that lets you plan routes and navigate tidal zones and be able to traverse these environments.
We'll be getting into a lot of different aspects of nautical charts today. Everything from the origin stories of nautical charts to what is on these little confusing buggers and how to figure out how to use them. Little nuances and things that you get to figure out over time, we will hopefully be able to cover in this video today. Alrighty.
When nautical charts were first being produced, they were hand-drawn cartographed atlases that were very hard to reproduce. They were these like sprawling combinations of art that took forever to make, and to have a chart was an incredibly valuable thing. That changed with the introduction of the printing press and the dissemination of information that it enabled. When charts were modified to be able to be mass-produced on the printing press, they relied on colored plates, which each plate was incredibly expensive and each color of ink was incredibly expensive, so they tried to limit the amount of plates that they would use for a single chart, while also being able to have the information color-coded. So to do that, they would minimize colors, but also combine plates.
Correct me if I'm wrong, there were only 2 plates that they really used. I guess a third, technically.
4-ish, but 2 colored ones.
Yeah.
They had a blue plate, which they would alter the color of by tinting it out and adding either less blue ink or applying white paint and making lighter blue while still using the same colored plate. This was used for water on NOAA charts and British Admiralty charts. The water had 3 colors: a very shallow, which was the darkest blue, contrary to what you might expect. And then there was an intermediate blue, which was slightly lighter, and then white was used for the deepest waters, so the middle of channels or the open ocean. They did that to aid in nighttime navigation, as the black text that was used for depth soundings and to denote obstacles was easiest to see superimposed over white, especially with the aid of red nighttime lights.
They also had a yellow plate. This was used to show where the land was, show up yellow for the land. This helped when you would place both the blue and the yellow plates together to create a green color for the intertidal zones, and that showed where those areas would be when the water was high to low tide.
And that was about it for the terrestrial and aquatic landmarks. They used a black plate for text, for shoreline, which was used, shown with a boulder line, and lighter, less heavy line weight was used to show the borders of intertidal zones and contour lines and roads and things like that. Also, depth soundings would be in this color, and any information in the legend presented in notes would also be in the same color of the thing that they were talking about. The
oftentimes intertidal zones were also marked differently in terms of, instead of a thick, bold black line, it was a dotted black line that was much thinner, just to change it up a little bit. I think that that's become far more commonly used now. I'm not sure if it was always the dotted line, but I know that on modern day charts it's a small, thin dotted line to show those intertidal zones.
And the final plate that they would use was a magenta plate, and magenta is an alarmist's favorite color, and was used to denote intangible borders, such as no dumping zones, ferry routes, and even landmines, areas where there were landmines underwater, and telling you to avoid those. The magenta was also used for any compass rose information, and isogonal lines along the compass rose to denote areas of equal magnetic pull. Notes about any of that would be in magenta, continuing the correlation, and those would also be found in little note appendices all over the chart.
Alrighty, so we will now give you an opportunity to look at your first chart. We're gonna run through different portions of the chart. We're going to explain what a chart legend is, things that you can find on it. Before Al shows you a full in-depth chart, just because this is right here, this is typically what a legend will look like. Shares legend right here, explains what the buoys look like, a little brief description, and then where they are on this map, and they correlate and go through that. You can also find on different charts fish species, so there is a much more in-depth photograph, or illustration, I suppose, of fish, inside the map, and just different ones, where they're located, as well as GPS coordinates, different courses and distances, the measurement that is used on charts, etc.
When you get a chart, it will have title information, and this titular information is usually presented exactly like this, and it will have a hydrology seal, so this is a NOAA chart, so it bears the NOAA seal. If it was a British Admiralty chart, it would have that seal, or a IMRE chart, it would be marked that way. Sometimes maps are put out by more than one hydrological institute, and so both of them would be up here. Here's the larger region, which on this map is the Alaskan Southeast Coast, and then there'd be the title of the actual chart, the passage to Cross Sound, and shows that it includes Lynn Canal. Then you have what projection it is, so this is a Mercator projection, and that includes the scale. The soundings in fathoms is here, which is super useful because it'll show you what actual unit you're dealing with, which is important to know, especially if you are in areas where several countries or denominations are present. And then there are some other notes. It'll tell you sometimes here or sometimes in a separate box your tidal datum. On this chart, it's up here, which gives you the number that they're measuring off their depths from. So on some charts, it'll be the lowest astronomical tide, which is the absolute lowest low that it has been recorded in extreme tides, so strong springs. This chart's datum is the mean lower low water, which is the average taken from all of the springs, the lowest lows of all of the springs, and that's the number that they use to measure up from.
So on different charts, you will find different symbols. Bear with me, I'm terrible at writing backwards, and so consequently none of this will really make sense in recording if you try to read the notations next to any of the drawings or symbols that I do.
Unless you're really good at reading backwards.
Or you pause the video. Whatever you would like to do. This, what it reads is, it is a triangulation point. Do you want to give any background on that?
Used in geological surveys to figure out where other things are in relation.
This is for any fixed point.
So like towers and lighthouses and buildings, all of those will be marked by that. Some charts, NOAA charts, have more specific, Admiralty charts have more specific markings to denote different kinds of structures coming out of the water, but on NOAA charts it will just be this circle to denote a fixed point.
The circle with a plus in it is an observation point
For astronomy.
which is rad.
Yeah.
And then the diamond with a point or dot in it is a boundary marker. That's about it. I will attempt to point this little iPad that we are filming on down to the chart, and Al will point with a nice little pen to the points that we are referencing. Bear with us. It is not the smoothest transition process. But yeah, it'll give you, hopefully, a little bit of a new aspect on what we are talking about.
There is a fixed point here. These are towers, marked by their TR. And I don't believe there are any boundaries or astronomical observations on this chart. There's another fixed point. This one is a spire.
Here is another fixed point, as well as right here. And then another one right here, which shares that it is a house.
These are cups.
These are cups. Oh, this one's a spire. But that one
That one's a cup.
is a cup, which is pretty wild. Alrighty, we are back with more shapes and colors, but way more shapes than any colors, to be honest. This is a really nice overview of symbols. Again, don't really bother reading the words. They aren't incredibly important.
They're for us and not for you.
Yeah, I wanted to have a little bit more of an explanation, but again, realized that it's pretty hard to read, anybody's writing with whiteboard marker, as well as the fact that you can't really read them backwards that well. So, starting all the way up here, two straight lines with little wiggly lines next to them. What are those, Al?
That would be an embankment,
Heck
which
yeah.
is cool because it gives you some information about what the topography of the shoreline looks like, which is really helpful if you're pulling your boats up on shore.
The next symbol, which is a line with a bunch of lines through it and then a square on it. What is that, Al?
That is a railway,
Nice.
right?
Pretty cool. And then the next symbol below it is...
You bet it's a tunnel.
Oh boy, those things are pretty neat. These symbols with a line going up and down with a 20 in the middle, and then a 28 with lines side to side. What does that mean?
Those are height clearances, so it would be 28 feet above, or meters, whatever the sounding unit is for the chart, will also be height, vertical height of clearance, so it would be 28 feet or meters above the tidal datum. So in this case, on the Booth Bay chart that we showed you, it would be 28 feet above the mean low water level.
And the next symbol, which is a dot dash dot dash dot dash. It almost looks like Morse code.
That would be an overhead cable for either electricity or information.
Awesome. And then just a regular straight old line.
An overhead pipe for liquid.
Crazy. On this side, we have a circle with a dot in it to a line, dot, line to another circle with a dot, which is a cable with a tower, or cables to towers. Continuing. Then we have a line to dot, line to dot, line to dot, which is a land pipeline, and the dot on one end or the other side of the line signifies the direction that it is going. The next symbol below is dot to dash 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 dot to dash 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 dot. That signifies a fence. Oh gosh.
Which can be on land or in water.
Crazy. A number in parentheses with just parentheses on either side is the height, signifies a height above the high water mark on any chart. The number, we have 30 as the example here, with parentheses around all sides of it, is the height above ground level, which are two different things. The massive box with the X through it signifies a place of worship, in general, any type, doesn't have a specificity to religion. However, it almost looks like a football goalpost with a little circle with a dot on the bottom. I was going to say an upside down Quidditch hoop.
Oh, yeah. With
but
legs.
Yeah, exactly.
Yeah.
Well, yeah, because it is just a pole into the ground. But the upside down Quidditch hoop with legs is specified to mosques. And then the plus with a bunch of lines on the ends of those plus is specific for churches, and very, very specifically within Christianity. Yeah, those are the cute, neat little symbols. We looked through the chart of Booth Bay that we tried to show you earlier, and we couldn't find a majority of these symbols on that.
Also the Lynn Canal chart.
We couldn't find them on our Lynn Canal chart. To be honest, any of our charts.
I expected this one to have pipelines. I'm kind of really surprised, actually.
Pretty cool that Alaska ocean charts don't have pipelines going over their water, which is pretty neat and also mildly surprising.
Yeah.
But very, very refreshing to see.
Not upset about it.
Yeah, definitely not upset. Alrighty. So, more symbols. Noah will use a circle with a dot in it, like we previously showed you, and explain what it is, but alternative charts will use different types of symbols. Al, you want to run us from the top over here?
For certain, this is how British Admiralty and Imre charts denote towers. This was a water tower with the same little conical guy with the water tank on top. This is a chimney, as in smokestack and not rock feature. This would be a flare. These little cottonwood seed type explosion looking guys are windmills. Flags look like flags. They also sometimes will be colored. Satellite dishes, which usually have magenta squiggly boundaries around to denote that it's a communications area and they don't want you to go there. Castles or forts are symbolized like this, and these two crossed pickaxes symbolize a quarry.
Please don't make too many comments on my whiteboard art. I'm trying my best.
I think it's lovely.
Thank you.
And we can't show you because very ethnocentric of us, we only have Noah charts. I apologize.
No, I feel like that's not fair to say that it's very ethnocentric, because there are British charts at the EXP house. We just don't have access to them currently. Also, there is no teacher like doing personal research yourself. So, to further your education after we give you this quick little overview, you can go and continue to educate yourself on charts. Look them up, they're cool.
Definitely look at an Emery chart because they don't do the water thing where light blue is shallower. They have the seemingly logical dark blue is deeper and light blue is shallower, which is cool and different from NOAA and Admiralty charts.
So I will be explaining the next two sets of symbols. I couldn't fit everything onto one whiteboard page, so I will explain this one, and then I will cover a second section. The top symbol with two dots next to it is posts and piles. Do you want to add anything else to that statement?
Nope.
The next one is rocks that are never covered. They will be sticking up out of the water. The next one is very similar, but it is rocks that will be uncovered at 2 feet. It's not always 2 feet, but your chart that you will be reading off of will note if there's a difference. If it's 2 feet, 5 feet, meters, whatever, it will write it out for you right next to it. This is rocks, a dotted or a plus sign with dots around it, and then a dotted rock outline is rocks that are uncovered on a particular chart datum. It will again share it on that specific chart, but uncovered at a specific water level. Then a plus sign with a dotted rock outline is underwater rocks. Those rocks will never be above water. Then you will have different direction facing lines with little tick marks halfway through them, which is a fishing stave. Al had to explain what a stave was, which is it's an area of safety for those fish, whether that be sometimes you can go fishing in Florida and there will be old shipwrecks or just areas where they've dumped cement and rebar into the ocean so that it creates a little habitat for commercial fishers to bring people out to, so that fish have areas to hang out. Anyways, then a little fish symbol is a fish haven, and then a sun with lines going out, or a circle with lines going out with little tick marks at the end of them is the limit of safety. Pretty neat information. Kind of going back to the fishing staves, they can also be shipwrecks, like small boats that are underwater. It's basically an area where you have something that's pretty low underwater and it creates a habitat for fish.
And could also be a hazard depending on how big your boat is or how low the tide is.
Alrighty, our second set of symbols is as follows. This arrow with dashes beneath it indicates the flood stream and the speed with which it moves. So it's not necessarily always 3 knots. It can change depending on the chart you're looking at. The next one is the ebb. It has a lacking of dashes at the bottom of the arrow, indicating that it is the ebb. It can be 3 knots, 10 knots, whatever it will look like. We have a bunch of waves, which indicates white water areas. This can be due to flood or ebbing tides. The area in which, where we were in Maine, had those the specific symbol at Hell's Gate, Lower Hell's Gate, when we were there. These spirals can indicate eddies, as it was noted in the book, or how Steve described them was whirlpools. Either or, I think that it would depend on the chart that you're looking at. A black dot indicates a new moon. A empty circle notes the full moon. Dashed circular line notes obstructions. A mini scaly fish drawing notes shoals. Rock strewn or awash, looks like a little asterisk. A line with a couple lines through it indicates a shipwreck. And then an arrow pointing one way or another indicates the mandatory direction of flow through that area and is typically drawn or indicated in a magenta color, as it's pretty important.
And alarming.
And alarming, I suppose. Yeah.
So, as a navigation aid and to help boats return to and leave ports, there's a system of buoys that is internationally recognized by the IALA, which is the International Association of Lighthouse Authorities. The IALA has two systems for codifying these colored buoys, the System A and System B. Most of the world uses System A, and IMRE charts and British Admiralty charts will use this system. In System A, what's the even odd number correlation?
Red cans. Red buoys will always have even numbers, and green buoys will always have odd.
And red buoys will often be in nun shapes, which start with a box and have a tapered point. It's like supposed to be a conical nun hat. Green buoys will typically be in can shapes, so just a bobbing can with a flat top and all flat sides. System A has red nuns on red buoys on your right side as you're embarking and going out to sea, so you can remember it by red right returning to sea, which lets you know to keep the red buoys on your right and your green buoys on your left. System B, which is what NOAA uses, has that as the opposite, and you could still use the red right returning phrase, but on these charts and in American territories, it is red right returning to shore.
Atop these buoys oftentimes are lights that will flash depending on the number of flashes, how long it takes, the seconds that are used within that. Those will be marked on each chart and explain. There will be little notations next to it, so sometimes it will have a little red, it will always have a red dot, similar to what you will find right here. So it'll be a red dot, and even if it's on a green buoy, it will still be a red dot showing that you get light coverage 365 degrees around. That is not always true in terms of where you are. You may not always be able to see those buoys, and when you can't necessarily see those buoys at a certain point, it will note it on the chart. So you may have a chart that shows you a red or green dot. For the sake of simplicity, I will go green to red so that you can differentiate. So typically they are noted in diamond shapes, surprisingly enough. And then you'll get a little red dot like this. Now, if you are over on this side of the can or the buoy, you won't necessarily be able to see light over there. So if you aren't necessarily capable of seeing light in a 365 degree fashion, they will show that you can see light that close up until this point, but you can see light from the can or buoy that far away at another point, just depending on the distance cut off. Light frequency is noted in seconds, with different notations next to it. Do you want to explain that?
Sure. The specifics of a buoy and a lighted buoy will be described next to it. So can I see drawing?
Yes.
Thank you so much. So, in the case of a green can that flashes in groups of 3, 12 seconds apart, it would have the little diamond shape, the red circle. Oh wow, you cannot see that at all. The red circle, and then written next to it would be FL to symbolize flashing lights, and then the color and shape of the buoy, so green can, and then in parentheses would be the number of flashes in a period, and then below that would be the actual period. So this has 3 flashes in a period, and if a period is 12 seconds, it means that there's a series of 3 flashes of light and 3 ellipses between those flashes every 12 seconds. And then also written next to it would be sometimes they leave it out, sometimes it's just the period of light, the color, and the shape, but a full light description would also include the height in feet or meters, whatever it is, on your depth soundings from the sea level, and also how far the light was visible.
You can also see the little notations right here on this little chart. So it is a green. Here. Let me see. Yep. Green 1. So we'll flash, and then sorry. Green. Yep, green 1 in the parentheses, and then flashing 1 G with 4 seconds between the flashes.
If you bear with us again, I'm going to flip you guys upside down. And this area is rife with buoys. Do you want to pick a buoy and point to the...
Yeet!
So, you see that it's a flashing light, 4 seconds, period, 20 feet above sea level, and visible for 5 meters.
Just pretty neat.
Really neat. And then there are some that just have green can or red none, and those are unlit day buoys. On the subject of buoys, sometimes they'll be used to denote danger, and that's particularly true in the case of cardinal buoys, which are traditionally black and yellow and have a hole on top with triangles that point you in the direction of the danger and tell you where to go, which cardinal direction to go, in order to pass it safely. So, Caper is drawing the directional diagrams, but in order, if the buoy is telling you to go north, it would be 2 triangles pointing upward. South is the inverse, 2 triangles pointing downward on top of each other, and then east and west get a little funky. East is a diamond, 1 triangle pointing up, 1 triangle pointing down, and west is an hourglass, so 1 up, 1 down, but in the opposite orientation.
These, when we saw them in Maine, they can most certainly be mounted on top of other red or green cans. Sometimes they are. The ones that we saw in Maine were sticking on the top of metal poles, which I indicated with these, and were rammed straight into rock piles that they were located on top of. I believe that we saw 1 or 2 of the east and west markers that were on top of buoys, indicating the directions that you wanted to travel within the channels. to avoid certain things. But for the most part, we did just see them driven straight into rock outcroppings that were above water during low tides, and below water or underwater, below water at high tides. But yeah, north, south, east, and then west. Aside from lighted buoys, the other major application of lights in charts comes with lighthouses. So on NOAA charts, the extent of a lighthouse's, the range that the light will reach, will be shown by a angled vector pointing out, and it will extend until the light is no longer able to reach, and then at the points of those lines, it would stop. On Admiralty charts, it's slightly more complicated and drawn in discs or circles, which show both the color of the light and how far it will extend, which is very helpful in busy harbors where there might be more than one source of light with overlapping sectors of light. It will show you all of those and what color the light will be and help you navigate. Can go along the lines of something like this. Typically they are on land, so imagine that half of this is cut off and you just get two different portions of visibility for light. But they are typically, like Al shared, noted in wedges going out. That concludes our charts, our nautical charts chapter. We hope that you enjoyed our explanations, descriptions, illustrations, and music that isn't ours. We hope you come again. Goodbye.